Hello everyone, today I will be going over the other calculator that you might have and you might be using, or the other model that I also have. So I will be going over some of the tips and tricks that you can do on this calculator, and again, just like last video, basically cheat on the exam. But once more, a disclaimer, this is no real cheating. I'm going to just show you many different tools that you might not have known you have on your calculator and that you can use to your advantage in the exam in order to save time or check your answers. And then if you're able to check your answers, you know if you got it right or wrong, and this can prevent mistakes from happening later on. I will be assuming that you know most of the calculator and how it works. I will go over most of the different modes, just like last time. So I might skip a few because they're not so useful, but I will be going over all the different modes in the calculator. So the very first mode is the calculate mode, and the calculate mode is again, just our regular favorite calculator where we can do basic calculations, so multiplication, division, subtraction. We can use our sine and cosine functions and figure out what different answers are, and that's very useful and that's great. So just like the other video, I'm going to show you guys how to store values from algebra, because a lot of people actually don't know how to use the variables, and it's really useful to store information in case you need it in the exam room. So we can see here that I have a large array of different variables: A, B, C, D, E, F, X, Y, and M. So if I click on any of them, if I just do alpha and the button that they are connected to, you can see that I can use these values. And you can check what their values are by clicking Shift and the STO to click to get the recall function. So since I just started the calculator, they are all set to 0. But let's see, how can I store a value? So if in the middle of the exam you're doing some complex calculation, and that's going to give you a really weird decimal, but you want to, later on, you might want to use the more exact value, even though on your exam paper you'd write it to 2 decimal places or 3 significant figures or something like that. You might want the more exact value later on. So you can store this value. The easiest one to store it as is X. You can click on STO for store, and you see that this icon starts glowing where it says choose the variable to store it to, and I'm going to click X, and now you can see it's done this. Answer goes into X. So now if I use X, X has been stored at that as that decimal value. That's how you store X. I've tried to do it this method with other values, but for some reason when I click alpha and then another letter, it doesn't work. But there is a way to do it. If we have a value, for example, if I do 9 sine 3 or something along those lines, I get this decimal. And then if I want to store this value, what I can do is I can click Shift Alpha. This starts a new line, a new calculation related to alpha, and I would click Calculate. And this calculate option actually is useful for some other things too, but more of that later on. The point is now it's given me this A, and I can store it as something. So I can write down a calculation to store it as, or I can just use my previous answer. So now I've stored A as the previous answer. I'm not sure if there is another way to do it. The manual says that you can use store, but it doesn't work for me. So if anyone knows how it works properly, please feel free to tell me. Then, just like in the other video, we also have different calculations that we can do. For example, differentiation, and find out what something is at a certain point on the curve. So if you want to find, for example, the turning point of a quadratic, like this one, then you might differentiate it and you might calculate it, and then you find out your x answer. And if your x answer is correct, for example, if you find out your x to be 2. When x is 2, then that means that the gradient of the graph must be 0. So I can, for example, try this. When x is 2, what is the gradient of the graph? And it tells me 7. So I got it wrong, but then I can try again. And then I can, for example, try something else. You try and try, and then you can finally get your answer, and then you can check it in the exam and see if it's correct. So that's one way to check your answers in the exam to make sure that they are all working. There are other options. For example, we have integration, but we haven't done that yet, so you can't use this yet. We have summations, which also we don't really need to use at all. I mentioned in the other video you do summations in FP1 so far, but we haven't used them, so we can leave them. One more thing that you might need to do is sometimes you have to switch between different units of measurement. For example, if currently I'm working in degrees, so sine of 90 degrees is 1, but maybe I want to work with different values. So if I click on Shift and then the menu, which will open the setup because I clicked the yellow option, I can choose the different types of formats, but I'm just going to switch the angle unit, which is option 2, into radians. And now let's try writing this out using pi divided by 2 gives us an output of 1, and pi divided by 2, pi over 2 radians is the same as 90 degrees, so that we can see that the answer works when we switch to radians mode. Those are most of the useful functions. We also have then in the options, there are hyperbolic functions, angle unit, and engineering symbol. Hyperbolic functions are things we haven't done yet. Angle unit, I don't really find too necessary. I think you can just switch between the angle units. And then there's the engineering symbols, which are similar to what which basically give you different values. For example, the option 3 is nano. So if I don't remember how much is 1 nanometer, I can convert it and it tells me it's 1 times 10 to the minus 9. So this is if you forget your conversion units in the exam to like have different values, you can use this in the exam room. And another thing is there's also this button ENG. If you have an answer and you want to switch the power of 10, so to switch the standard form, you can click on this. And well, if I click shift this, it goes in the opposite direction. So here I can make it into a longer decimal. Here I can see what it actually looks like just as a decimal because this is to the power of 0. But if you just click ENG without shift, it brings it backwards. And then with shift, it brings it forwards. I mean, decreases the power of 10 or increases the power of 10. So that might also be useful for you to know in the exam, in case if you want to use it. The next thing is that just like on the other calculator, it basically is the same calculator, just all the functions are in different locations. We have the convert option, which allows you to convert different values. So for example, velocity, I can go from kilometers per hour to meters per second. So if I put 1 kilometer per hour, convert that to meters per second, and then it gives me the answer of 0.2777. So this is the exact same calculation I did on the other video. And there are a bunch of other conversions that you can check. You might also have different constants. So if you remember, we did look at this. Constants, sometimes they ask you to memorize some constants for the exam. And if you forget them, you can always check in your calculator. For example, here, if I go in universal and I click on option 3, which is CO something, this is the speed of light. On the other calculator, it was just C, but it's still the speed of light, and it's a very exact value. In the exam, we only have to know it as 3 times 10 to the power of 8, so 300 million, but you can use this more exact value to help you remember the simplified value in case if you forget it. So that's something useful to know. In the other video, there was also a function that you could store on the calculator. I have not seen this. This is not for this calculator version. You cannot store a function inside of the regular calculate option, which is a shame, but that's how it is. And that's everything really to do with the regular calculator. The next section is the complex section. In this calculator, the order of the sections is different, but it's the same. This section is the exact same as the other one. Here you can see that I've got this little eye symbol that's glowing here now. It shows you that you are in the complex section. You might be wondering, how can I get the imaginary number I? And you'll notice that it's over here in purple. But purple isn't one of the options. It's not shift or alpha or something like that. Instead, now the ENG button has been switched when you're in the complex mode. Now it is the imaginary number. So if I just click it, I get the imaginary unit. And yeah, that's it really. We can do basic calculations before that required complex numbers, for example, complex multiplication, and then it gives you your result. And this is useful again for the exam if you want to check your answers and make sure you did everything right. This is how you can do that. Of course, there is the buttons where you can, for example, find the conjugate. So for example, 2 plus I, its conjugate is simple, it's 2 minus I. So I feel like this button is a little bit unnecessary. If you have your whole equation written in the form A plus BI, then you just have to switch it to A minus BI. There is also the more useful probably is the argument option, which helps you to find, well, the argument, the sort of angle, quote unquote, in your complex plane. If I have the image up here again. So if I pick a simpler one, which will be nice. So for example, 2 plus 2i. So this is going to give us a 45-degree angle, but because we're in radians mode, 45 degrees is the same as pi over 4 or quarter of pi, since I'm using radians. And then if it's negative, it will consider that and it will use the quadrants on the arcane diagram to find out what the answer would be. So for example, here's minus 2i. So if you remember how to calculate it, you can try it for yourself. I hopefully have a picture on the screen right now, so you can see where the different lines would go and what the argument would be. And then the last section is just the same functions from the regular calculate option. So nothing else new here. And that's basically just all of the complex numbers. The next section is base n, and just like with the previous video, I discussed that I won't be going through base n because I actually don't know how it works, what it's used for. Apparently it's different ways of writing things out or something, I think, based on what I did find out in the end, but it's not necessary so far in our course. If it does become necessary, I'll make a video on it later on, but so far, not so important. The next option in this order, the fourth mode, is matrix. And the matrices, it's quite similar. I prefer this layout actually. So immediately at the beginning, it asks us which matrix we want to define. So for example, I would like to define matrix A. So I click on 1. And then it asks me how many rows do I want, and then the next question will be how many columns do you want. So in further pure math, so far we've only done 2x2 matrices. We might have to do 3x3 later on, but so far it's just 2x2. So I can click 2 rows and 2 columns, and then it gives me my matrix, and I can put in some values. And then I can store it by clicking equals one more time, and then AC. And this puts me in the matrix calculator, the actual one. So if you want to see your stored matrix values, you just click on option, and then it gives you define matrix, edit matrix, and then your different matrices. So we can define more matrices if I just click on 1, and then it gives me more options. I can edit a matrix. For example, I have matrix A saved, so I can quickly edit it if I want. And then I can use the matrices by clicking 3, 4, 5, or 6. So Matrix A is this, just like I wrote out before. We could somehow manipulate matrix A, for example, if I multiply it by 2. So all the values increase by 2. We can see this is the new matrix. We can also have, if you scroll down, you can also have the answer matrix, which is the previous calculation you did, the solution you got there. So, and then there's also the determinant, which is, as we know, AD minus BC. We can use that, for example. So determinant of, let's do the answer matrix, and then it'll give us the answer is minus 12. So the answer matrix, which we calculated, which was double of the matrix A that I put in, gives me a determinant of minus 12, which means that there is an inverse matrix for this answer matrix and also probably for just matrix A. And then there's also the identity matrix, which is option 4. So if I click on the identity, it asks me to put in a value. This number you're going to put in is how big you want the matrix to be. It's always going to be n by n long. So I'm going to put in 2, which means a 2 by 2 identity matrix, which is just 1001. I can also do a larger identity matrix. For example, this one, which is the 3 by 3 identity matrix. In the last video, I read this out and it sounded like I was rapping, honestly, but I'm not going to read it out this time. We have this transposition. We haven't done that yet. We don't need to know it. And then, of course, our regular functions, which we might use, such as hyperbolic functions, engineering symbols, if we're working with big numbers, etc., etc. If I, for example, were to specify what matrix B was, define matrix B to be 2 by 2 also, and then I say it's going to be 1, 0, 2, and 5, then I can store that and I can do my matrix multiplication. So for example, matrix A times matrix B, and that will give me my answer matrix. So this is great if you're calculating something and you want to multiply matrices quickly, because sometimes it can be long and arduous to do that. So this is a great way to quickly get that done. The next section is vector, which is similar to how the matrices section is, but again, it's slightly different. So if I open it, it asks me, just like with the matrices, define a vector. So I can choose to define vector A, B, C, or D. Let's just start with A. And then it asks me for the dimensions, because vectors can be 2D or 3D. Vectors represent some sort of movement in dimensions, but so far we only work with 2-dimensional matrices. So I can click on 2, and then it shows me the vector, which I can store information for. The way the calculator writes out vectors is what we call a column vector. This is one way of writing it. You can think, if you prefer the ij notation, think of the top value as I and the bottom value as j. So if you were to write this in ij, it would be 2i plus 3j. And then if I click AC just to open the regular menu, I can press on option. I can define more vectors, edit vectors, or use them. For example, I can access vector A, and maybe I choose to multiply vector A by 2. So 2 times vector A, and then I just doubled all my values. Another thing I can do is I can have the vector answer, which is just the previous answer vector. The others, I don't really know how they work properly, and they don't seem so useful. I thought angle could help you with calculating the angle of the vector, but it didn't really work for me. And then of course you have your regular set of values from also the calculate option with the engineering symbol, hyperbolic functions, all of that. So far, I haven't seen this been useful to us. Maybe when vectors become more complicated later on, we might have some more useful tools, but then I'll talk about that when I have to make the video then. The next option is statistics, which is a great section if you're doing S1. If you've seen the other video, you'll know how many useful tools this section can have. So far, we are only using one relation, which is the one variable one. So if I click on it, Then I have my x values. So if I store a few values, for example, the height of students in a classroom, then I can, this time I can't just click equal sign to get all my answers, that you go into options and then you can click on one variable calculations, which is option 3, and it shows you all of the information related to it. You've got the standard deviation, the variance, the sum of x squared, you've got the median, the lower quartile, upper quartile, the minimum value, the number of values, and also the maximum value. So this is great because it basically shows you a whole bunch of information related to statistics really quickly in one go. That's just super useful in general. If I, for example, also had frequency in my table, I could quickly activate the frequency column by clicking on Shift, Setup, and then if I scroll down, I find the statistics option, option 3. And then do I want frequency on or off? So I want it on. So I click on. And notice that this does erase your data. So please take note that if you have information, don't write it and then add the frequency table, and make sure to do it later on. Let's rewrite a bunch of different student heights. When you first put in values, it automatically sets the frequency to 1, which honestly is slightly useful. So technically, I'd always keep the frequency table on for myself, and I just leave it as 1 if it doesn't give me frequencies, because then it's technically then I have it easy to access. But of course, you can always switch off the frequency table if you don't like it. But let's now say I have a certain number of students with the different ranges of height. Now, if I've stored all the values with different frequencies, I can click on option and then again the calculate option, and it gives me the detailed information once more, but now it is more correct. It's got the total number, which is 20 this time. It's using the frequencies to calculate everything. It's all in relation to each other, and we can see how it's all linked. There are some other options here, but these are not too necessary. There's a statistics calculator, which I think allows you to use the values from the calculator. I was looking at this in the manual. The only problem is I couldn't find out how to store the values. There's also, of course, our one and only favorite 3 sections that you can always access basically anywhere. And that's basically a quick rundown on the statistics section so far for S1. If there's more information that I learn later on, or if it's more useful to do calculations on the calculator too, I'll figure out how to store the values more precisely. But for now, this is already quite a lot of useful information. The next section is distribution. Now, we do distribution in statistics, but we haven't done it yet. So I'm not able to explain this or go through it. I'll probably make an updated version of the video later on where I do go through distribution, because I don't know how some of these things work yet, so none of them are really useful to me. But I will go through distribution once we get to it. The next option is a spreadsheet, which, similar to the other calculator, is quite literally just a spreadsheet. I'm not going to go through this because it's not too useful, not too important, nothing like that. You can do different like Excel calculations. You can find the sum of something. It's basically a mini Excel spreadsheet on your calculator, but it does. I haven't seen this used so much, because if you want to write sums of something, or if you want a table, better to write it actually on paper or use an actual Excel spreadsheet, because this calculator has limited storage. But you can still use this, I guess. There are some ways to copy paste, recalculate, and grab values. So I can select this one and I can move it. It's interesting. There's probably a lot of great functionalities to it, but it's not something I'd use in the exam room because it does take a lot of time and it is time consuming. Maybe it's useful to you, so feel free to check it out. I'll leave the manual in the description that you guys can look at. The next option is tables, similar to the table from the other calculator. Well, we can use this to represent functions. Now, even though in this calculator we don't have functions in the calculate section, we can do them here. So if I click on table, it immediately asks me to define a function, for example, f of x. So I can define it as x plus 3. So I can define a function, for example, this one, which is quite complicated. And then it can also ask me to define g of x, which is another function. So I'll make a simpler one here. And then for this calculator, it asks you to choose a range of values. So for example, choose a starting number and an ending number. So it's going to give me answers from 1 to 5, increasing by a step of 1, which means it's going to be the values of 1, 2, 3, 4, and 5. I can change the step, for example, to be 0.5, and then maybe this to 3. So now it'll give me values from 1, 1.5, 2, 2.5, and 3 with a smaller range. And if I click equals, it gives me those answers. And we can see what the solutions are here. So we have all our different values from 1, 1.5, 2, 2.5, and 3. But then it does have this empty row at the bottom where I can just add my own values. So I see maybe there's a pattern somewhere here, and I'm like, oh, maybe there's a root somewhere there. So I can click on the button and I can work towards it and just try to get closer and closer. So somewhere in between 1.5 and 2. So this is I would use this for interval bisection in FP1. So if you do FP1, this might be a nice way to do it, but also you can use this just to visualize different points on a graph. It's just useful to see functions in general. The next section is probably one of our one and only favorite sections, which is the equation/function section. So the equation section is just for solving different kinds of equations quickly. So for example, simultaneous equations and polynomials. Let's start with simultaneous equations. Most simultaneous equations that you'll do will only be with 2 unknown values. You might on occasion have 3, rarely at all 4 in the exam. I don't even think they do 4. But if you have a simple simultaneous equation with x to the power of 1 and y to the power of 1, then you can solve it quickly. It asks you to write your 2 equations in this form where you have the value of x, the value of y, and then it's equal to an integer. So for example, 2x minus 3y equals 8. And then maybe I'll do 8x plus 1y equals 20. And then we'll see, so if these are your 2 calculations, then I can press equals again, and it'll give me my answers. So x is this, and y is this answer. So this is a very quick way to solve simultaneous equations or check your answers. Maybe there's a way that you can check your answers using simultaneous equations here. And that's very nice and very useful. If we go back, then we also have the polynomial section, and it asks us polynomial degree. So a polynomial is just the values with different x powers, so like x squared plus 3x minus 2. So those are polynomials. So I can select the degree. We're basically only ever going to have to solve quadratics. So it's going to be a maximum of x squared. So you press polynomial degree 2. And then I can solve for this. So here we have 2x squared minus 8x minus 9. Imagine that's your polynomial and you want to solve it. Then you just press equals. Oh, I didn't guess it correctly. But either way, here it writes it. So this is your polynomial. So with the values. And then when it's equal to 0, x is equal to this. Now this is the first value of x. You can also have the second value of x, which when you scroll down, x2 is going to be this. So this is the second possible value. Of course, you can convert it to decimals if you prefer. Those are the roots of the quadratic equation. And then it can even tell us the minimum point of the graph y equals the quadratic. So the minimum point, which would be the turning point of the graph, because we got a positive x squared, it's a smiley face, and the turning point is going to be x equals 2 and when y equals minus 17. So we can use these values, and that is the coordinates of the turning point when the graph turns into the opposite direction. So if you can find this turning point using differentiation for when the gradient is 0, Or you can even use this section in the calculator to find the turning point, which is the minimum, or if it's negative, it's going to say maximum, so max. But that is how the polynomial section works. We are basically never asked to solve a polynomial that is to the power of 3, a cubic. Sometimes we do get quartics, but the special thing about the quartic equation is that they never give us a x cubed or just an x. So what happens is you're able to convert it into an equation of a quadratic by saying like y equals x squared and then putting y into the equation, and then you solve it during using that method. So you still don't really need to use the quartic section. Next up, we have inequalities. It asks for a polynomial degree, and then it asks us to find the values when x is greater than 0, less than 0, greater than or equal to, or less than or equal to 0. So this is great for the discriminant when you're trying to calculate a value of k, for example, for when the lines never meet. So that's when the whole thing is less than 0. So if I then give an equation, for example, 4x6 minus 8. Then we find out that, okay, that means that if the equation is less than 0, the discriminant with k will be this. So this is an example of like one of those questions you could get on the exam. I'll put an example question here so you know what I'm talking about, but you can use this to help you solve that. Because once you find the equation of the discriminant as an inequality, you can solve it. And it even here tells you which way to put your signs, because I always mess up the signs. So here it's perfect because it tells you if it's less than or greater than something, and you can use this. Of course, again, this doesn't give you all your marks. Doesn't show you're working out. You have to find the discriminant first and then calculate it, and then see is it the same as the calculator. But remember, your calculator can make mistakes, so don't always trust everything the calculator tells you, but it's still useful to check. And the last section is ratio. The ratio section is not that interesting in my opinion. I feel like you could do this yourself anyway. So I wouldn't use this because literally I just put in the ratio and I asked it what happens when I triple this ratio. So instead of this 3, I get a 9. So to get from 3 to 9, I do times 3. So then I'm going to do the same on this side. 9 times 3 is 27. And it calculates that. So honestly, this one doesn't seem so interesting or useful to me. I would use the ratio option personally, but because this is just fractions that you could do yourself using the calculate tool. And those are all of the sections on the calculator. So thank you. I hope that you learned something new and you have managed to get a better understanding on how to use your calculator to the full advantage that you have it, because it's perfect and great to use in the exam to check values and confirm things. Remember, be careful with how you put things into your calculator, BidMass wise, using brackets if necessary, because your calculator might still make mistakes. So you have to also remember to think in the exam. This is great for checking the answers, but it's just the answers. A lot of the marks come from your own working out.